Okay, so it's asking us to write an explicit formula for the sequence. So it's got this, this, this. These are the terms. These are fancy looking terms, aren't they? So basically what we want is we want a formula. This, some kind of formula, this is the first term, so it comes from n equals 1. Some kind of formula, like, I don't know, 3n plus 1 over 7 to the n, or I'm just making stuff, I have no idea. Some kind of formula like that where you could plug in 1 and you'd get that. And then this one, you'd plug in n equals 2 and you'd get that. And this one, you'd plug in n equals 3 and to this formula. It's one formula, and you're going to plug in these different n values. You know, we always start at 1. And just go up the line, plug in n equals 4, and you get that, right? Plug in n equals 5, and you get that. Plug in n equals 6, and you would get that. So what, is this the formula? No, obviously that's not it. But some kind of formula where I could plug in those numbers, n equals 1, 2, 3, 4, 5, and 6, and I would get these things. Well, how can we do that? It's a little tricky. So let's just start right here. Let me just grab one kind of in the middle. And let's think, first off, what's the connection between the 4 and the 3? What's the connection between the 3 and the 2? You see the pattern? We're like a scientist looking for the pattern right now. The 5 and the 4. Do you see how the power on the E is always 1 lower than the N? You see that? It's always 1 lower. All right, so first off, we can see the formula is going to look something like this. It's going to have e to the n minus 1 minus and plus, right? It's always minus on the top, plus on the bottom, minus on the top, plus on the bottom. And the power on the E is always 1 lower than the N, isn't it? So it's n minus 1. You see that? So far, so good? Okay, now what about the numbers in the front, like 12, 11, 10, 9, 8? How are those? Well, again, look for the connection. What's the connection between 5? I'm just doing the numbers on the top first off. 5 and 11, 6 and 12, 4 and 10. Just looking for a connection. 3 and 9, 2 and 8. What's the connection there? Add 6, right? 3 add 6 is 9. 4 add 6 is 10. 5 add 6 is 11. See, the number there is 6 higher than n, isn't it? 6 add 6 is 12, right? So therefore, this piece of the puzzle must be n add 6. You with me? Okay, now what about the bottom? 2 to 4, 3 to 6, 4 to 8, 5 to 10, 6 to 12. Do you see the connection? What's happening there? It's times 2, isn't it? It's doubling the n number. See that? So that's 2n. Now, wait a minute. You might say, okay, I got all that, Ms. Taryn, but what about this 6/3 thing over here? I mean, that looks like totally different than the other ones. Well, maybe, maybe not. Let's try it out. What if I take n equals 1 and I plug it into this formula right here that we just created? I think we'll find something amazing happen. Plug in a 1 for n, right here, 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 and here, right? Those 4 places. So 1 here, and plus 6 minus e, and we'll put everything else in plus e, and this is 2. Okay, and I'll plug in a 1, put a 1, put a 1. With me, I just put a 1 here, 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 and here. I plugged a 1 into our formula, right? Okay, let's work that out. What do we get? 6 and 1 is 7 minus e to the 0, right? 1 minus 1 is 0, over 2 times 1 is 2, plus e to the 0, right? 1 minus 1. So 1 minus 1 is 0. Okay, now the question is, do you remember what e to the 0 is? or anything to the 0. Any number, here, let me just call it x. Any number to the 0 power is 1. Do you remember that? So this is 7 minus 1, even in e, anything to the 0 power. This is 2 plus 1, which is 6 over 3. Beautiful, which is what it's supposed to be. The formula's working perfectly. It does work for that first one. It's just that e to the 0 is 1, top and bottom. And so it works perfectly. Yes, it's 6 over 3, and it works for all the rest of them also. You could test it out for any of them. Plug in a 2, for example. Plug in a 2. What do you get? 8 minus 2 to the e to the 2 minus 1. That's e to the 1. 8 minus e to the 1 over. Plug in a 2. 2 times 2 is 4. Right? 4. Plug in a 2 here. E to the 2 minus 1. E to the 1. 4 plus e to the 1. Yeah. Bingo. Beautiful. That's it. That is indeed the golden formula. That one is the formula that they're plugging n equals 1, 2, 3, 4, 5, and 6 into, and they're getting these results. There it is. We just did inductive logic. We just reasoned logically. That's inductive. That's what a scientist does. Inductive logic. They look at the patterns in the sky, the human body, and magnetic forces, whatever, and they look at nature, the created universe, and they say, hey, what's the pattern? What's making this stuff happen? They look at this that's happening. They go, what's the rule there? When you look at something, observe, and you take it back to a rule, that's called inductive logic. That's the heartbeat of all of science. And there we go.